Okay, today I want to work on the assignment sheet number 2 from the unit, the step voltage regulator. Question number 1, study the diagrams below and answer the questions which pertain to those transformers. Okay, question 1A is what is the voltage induced on coil B? Coil B is the secondary of this transformer. Um, the video I made for you recently on the load tap changers, we talked about mutual inductance transformer um, being defined by the formula um, primary voltage over the secondary voltage is equal to the number of turns in the primary divided by the number of turns in the secondary. Okay, if we just plug in the numbers that we know here, the primary voltage is 100 volts, and we want to know what the secondary voltage is. So if we plug in the primary voltage of 100 volts, the secondary voltage ES is what we're looking for, and then the number of primary turns, 100 turns, divided by 10 turns in the secondary. So to solve this direct proportion then, wait a second, no, that's right, okay. So if we cross multiply, we get 100 times ES is equal to 10 times 100 is 1,000. So then if we divide both sides by 100 to get ES by itself, then ES is equal to 10 volts. So the voltage induced is 10 volts. This transformer would be classified as a mutual inductance transformer, and that's because the primary and secondary are not connected to each other. They're only linked by the flux that links the two. Okay, this transformer is a step-up, step-down transformer. The primary is 100, the secondary is 10 volts, so it stepped the voltage down. Okay, on to number 2. In this one, the primary voltage is 120 volts. We want to know what the voltage induced in the secondary, or coil B, is. So we can go to the old reliable equation, EP over ES is equal to NP over NS. Okay, we know the primary voltage is 120 volts. The secondary voltage is what we're looking for. The primary turns is 10 turns, and the secondary turns is 14. So if we cross multiply this, we get 10 ES is equal to 120 times 14, and that equals 1680. Okay, if we divide both sides of this equation by 10 to get ES by itself, we've got ES is equal to 168. Let me get rid of that. 168 volts. Again, the only thing linking the primary and secondary is the flux. The two aren't connected to each other. So this is classified as a mutual inductance transformer, and it actually stepped the voltage up, so we're going to say this is a step-up transformer. Okay, on to number 3. What's the voltage across the load side? This is the load side, the secondary. And back to the old reliable program or formula again. EP over ES is equal to NP over NS. Plug in your numbers. The primary voltage is 100 volts. The secondary voltage is ES. The primary turns is 1,000 turns. And the secondary turns is 100. So if we cross multiply this, we get 1,000 ES is equal to 100 times 100, it'd be 10,000. So if we want to isolate ES, then we divide both sides by 1,000. Here we end up with ES is equal to 10. So the voltage in the secondary then is 10 volts. Again, it's a mutual inductance transformer. And the voltage was in at 100 volts and the output was 10, so it's a step down transformer. Okay, on to the next one, number 4. What's the voltage across the load? Okay, this is an auto transformer. And we know that because the primary is connected to the secondary right here, so they're both magnetically coupled and they're electrically coupled because they're connected here. So we're going to have to approach this one a little bit different than the other one. The first thing we need to know is what is the voltage induced in this secondary coil. We can use the same formula we've been using all along. EP over ES is equal to NP over NS. Primary voltage is 100 volts. The secondary, we don't know. The primary turns is 1,000. The secondary turns is 100. So cross multiply 1,000 ES is equal to 100 times 100. It's 10,000. So if we want to isolate ES, we divide both sides by 1,000. And then we get ES is equal to 10 volts. Okay, now we want to know the voltage across the load. Well, first of all, we need to think about, is this thing connected in series aiding or series opposing? This is the way I usually do it. I'll start at the bottom and I'll trace my way through. So I go negative through positive, then around here through the negative, back through the positive. So it's minus plus, minus plus. So these two voltages are going to add together. So this is series aiding. And by series aiding, we mean that the output voltage then, since this is connected across the top, and if your load is out here, it's going to be connected then across the sum of these two voltages. This voltage is 100 volts. So let's say the E of the load is equal to the primary voltage plus the secondary voltage. And that's 100 on the primary plus 10 on the secondary. So you've got 110 volts on the load. This transformer, as we said, is an auto transformer because they're electrically and magnetically coupled. And this transformer is a step-up transformer because the input voltage was 100 and the output was 110. Okay, this one is a little trickier now. Study the diagram of a 2400 volt regulator and answer the questions below. Note the polarity and the fact that regulators regulate to a maximum of plus or minus 10%. So, let's see. In A, if the reversing switch is at position 1, what's the voltage between A and C? So, if the switch is connected here, okay, so that means your path is this way. Get rid of those, get those out of the way. So we know this is 2400 volts. This is minus, plus, and then between A and C, then we're actually not going through this other coil. A is actually connected right here to the top of this coil, right? Since there's 2400 volts there, and A is connected directly to the top of that coil, then the voltage between A and C, which is actually the voltage across this coil, is 2400 volts. So EAC is equal to 2400 volts. Okay, now what if the reversing switch is in position 1? What's the voltage between B and C? Okay, B and C, let me go ahead and get rid of these lines on here. Okay, you're still connected in position 1, but now between A and C, you're going to go through this coil, down through this coil, and over to B. So really, this voltage between these 2 points then is the sum of these 2 voltages. Now, we need to know, are these connected series aiding or series opposing now? Okay, we go through, like I said before, minus to plus, and then plus to minus. Minus to plus, and then plus to minus. So that means these 2 voltages are series opposing. So how do we find this voltage from B to C then? He said the maximum of plus or minus 10%. So we're going to say this voltage is 10% of this voltage. So the voltage A to B is 10% of 2400, and that's 0.1 times 2400, and that's going to be equal to 240 volts. So we said it's series opposing, so what's going to happen then is this is going to subtract 240 volts from the 2400 that's applied. So voltage B to C is equal to 2400 minus 240, and that's going to be 2160 volts. Okay, if a reversing switch is at position 2, what's the voltage between A and C? Okay, let's go ahead and get rid of all this stuff here. Okay, we need to get rid of that switch. We're saying this is on position 2 now. So now when it's in positions 2, the voltage between A and C is going to be through here, and down through this coil. So it's going to be... Oh, wait a second, I drew that wrong. Let me erase this. I got a little bit in a hurry there. So it's going to be up through here, down through here, back up through here, and into there. Okay, so when we go through there, then it's minus plus, minus plus, minus plus, minus plus. That means these voltages are both in the same direction, so they're going to be series aiding, okay? So voltage from A to C then is going to be the sum of these 2 voltage, 2400 volts plus 10% of 2400 is 240. So the voltage then is 2640 volts. Okay, I'm going to leave D for you to work out.